So, hello everyone. Welcome to the second tutorial session of problem solving through programming in C. So, this is an NPTEL course which has been floated by Professor Anupam Basu from Department of CSE IIT Kharagpur. I'm Siddhant and I'm one of the four TAs who will be handling this particular course. Specifically, these sessions will discuss your doubts regarding the previous week's lectures as well as it uh, will solve some sample problems to help you out with the assignment questions as well as with the final exam. Okay, so in the previous class, if you have been following these sessions from my side, I asked you to draw a flowchart to extract all digits from a natural number. So this is basically the flowchart. So we have, so n is any natural number. So we have taken 345. So we are starting this flowchart from here. We read n and then the first step is we calculate x, which is basically n percentage 10. So anything percentage 10 will give out the remainder. This is the remainder function, if you remember. So here we will get 5 as the remainder, and then we'll print x, that is print 5. Now the next step is we will change n. We have to bring it down to 34 because those are the remaining digits that we need to print it out. So what we will do is we will do n is equal to n minus x whole by 10. So 345 minus 5 divided by 10, that is 340 by 10, that is 34. Then after that we check if n is greater than 0. Yes, 34 is greater than 0. So it goes back here. It again calculates x. So x is 34 percentage 10 because n is now 34. So it calculates 34 percentage 10, which is basically 4, and then we print 4. Now the next step is we recalculate n. Now n is equal to 34, that is n minus x, that is 4 divided by 10. So it gives us 3. Now 3 greater than 0, yes, it is greater than 0. So let me write this. Okay, now 3 is greater than 0, yes. So it again goes back here, it calculates x. Now x is how much? 3 percentage 10, which is 3. And we print that, and now n is equal to 3, that is n minus 3, that is x, divided by 10, that is 0. So now n is equal to 0. So the condition is not satisfied anymore, n is not greater than 0 anymore, so it will stop. So this is how you extract all the digits from a natural number. I hope that's clear. So next what we will do is, this is one of the, some of you in the previous class had asked this doubt regarding what exactly was the correction in the previous week one's lectures regarding this averaging of n numbers. So I'll just quickly go over it. So we read n, that is the number of integers or number of numbers that we need to check the average of. And then we save this n in another variable m, because the value of n will itself change, as we will see later. So then we define a sum, a variable called sum, which is 0 initially. We read a number x, we add it with sum, and we subtract n by 1. That is, we are reading one number, so we have one less number to read now. So say initially we had 10 numbers, so after reading one number we reduce it to 9, so we have 9 numbers left. So then n is greater than 0, so say 10 numbers, so now we have 9 and 9, so 9 is greater than 0, so yes, it will go back here, it will again read a number, it will add it up with sum, and it will reduce n to 8, and so on till n becomes 0. So when n becomes 0, we have already read 10 numbers. So after that, this condition is not satisfied anymore, n becomes 0, so it goes here and we calculate the average is equal to sum by m, because m, if you remember, is the same number. We are just saving it in a different variable, the initial n numbers that we wanted, and then we print average and stop. So I hope this is clear to you. So okay, so the next thing that I'll be covering here is a kind of theory that we read uh, in the week 2's lectures. So there are two kinds of software that is possible, like application software and system software. Application software interacts with the system software, and system software interacts with the hardware. and user can interact with the application software as well as with the system software. So okay, so application software is like we have this PowerPoint and Excel and say VLC. All of these are application software which actually interacts with the system software. System software is we have Windows, we have Ubuntu, we have Mac OS. So all of these are system softwares, operating systems, and compilers and interpreters are also system software. And what they do is they convert the high level language to the machine level language. So all the software IDEs come with compiler or interpreter, because whatever we write, so this is C, we write uh, the code in high level language, and that has to be converted to a machine level language by some software, that is a system software which is a compiler. So there are predefined compilers that are available, and the integrated development, so this stands for integrated development environment. Okay, so this is a package under which, so whenever you download a IDE for C, so it will come with a compiler inbuilt. So it will have an interface, you will have a compiler, so the GUI, you will write down the code in the GUI, and then you will have the the compiler compile the program, and you get the machine version, that is the a.out file. So these are a few different kinds of OS systems that are available. Okay, so going to the next. So we also learned in this week regarding the syntax and the variables and how to name the variables. So this is basically variables, as we know, are memory locations in the RAM, which are allocated during compile time. And this naming of variables follow a convention, follow a particular convention. First thing is that it can be alphanumeric in nature, along with some special characters such as underscore and so on. The second point is that it shouldn't start with a number. This is quite important. It shouldn't be a keyword. So this keyword is basically reserved for some special purpose in C. So we cannot use this keyword as a variable because it will create a conflict, because there is something that has been predefined in C, that is this keyword. So um, because it has a special purpose in C, we cannot use this keyword as a variable. Now the next point is that it's case sensitive. So what does it mean by case sensitive? Say I write this as a variable and I write this as a variable. So both are different variables. This has a capital A, this has a small a, because being case sensitive means that these are two different variables. Okay, so that's what it means. And the final point is that it's a recommendation that it should not start with an underscore. Why? Let us look at that. That is a question that I have. So variable names beginning with underscore is not encouraged in C. Why is that? So the answer is that uh, it will create some conflicts since some library routines use such names. So if you go into the default the predefined library of C, you will see that there are certain library routines which starts with the underscore and then say lib something something. Okay, so this is some kind of library. So this underscore, it starts with the underscore. So if you have a variable name which is starting with the underscore, it might uh, the C compiler might think that you are actually using a library routine, so it will check against the existing library routines and it will not be able to find it. So it might throw an error in some cases. So it's better not to use variable names which start with an underscore. Okay, so keeping that in mind, let us see which of this is an invalid variable name. So the first one, you can see it starts with the it's alphanumeric. It doesn't start with a number, and it is not a keyword. So yeah, this is fine. First is fine. The second as well. It doesn't start with a number. It's alphanumeric in nature. It has underscore somewhere in between, That's all fine. So the third one, you see, it starts with a number. So the second point that we had here is that it shouldn't start with a number. So because this starts with a number, this is an invalid variable name. Now going to the fourth option, it has an underscore. It starts with an underscore. It's not really recommended to start with an underscore, but it starts with an underscore. But it is not any library name. It's there are no library routines with this name, so it is still fine. It is still valid as a variable name. Okay. Now we also saw the basic structure of a C program, the how it needs to have a main function, and there can be more than there can be other functions as well, and there are a lot of predefined functions in C. We saw all of those things, and keeping all those things in mind, let me just write that down. So first we have this return type, and then the function name and parameters. We start this. We write some statements. So after writing statements, we write some return and some variable, and we end it with a curly braces. So whatever is within the curly braces are basically our statements, or it's a block of code that we write, and this is the return type of the function. Let me write it for the main function. So we write int main empty bracket, so no parameters are passed. Then we have, say, some compound statements here, and we say return 0, and we end it. So this is basically the most basic function that we can have. This is a main function. Every C program needs to have a main function. Okay, it needs to have a main function because the main function is where the program execution starts. Okay, the program execution, it will start in the main function. Okay, so yeah, now it has a now there are inbuilt library functions, like say we have power function, we have sqrt, mathematical functions, then we'll have exponential functions, we'll have rounding up, rounding down functions, so on. There are a lot of functions here. Okay, fine. We know the basic structure of a C program, but next what we need to do is we need to think about variables. What are the different data types and so on in C? And when we think about data types, a particular data type, very commonly used data type is int. So there are different data types. There is float, there is int, there is char. Okay, so this is a integer data type. It can store integers. This can store floating point data. This can store character data. Okay, so say for int data types, ordinary int data types, where is the sign of the integer stored? So integer can be negative as well as positive. So where is the sign of the integer being stored in case of ordinary int variable? So as you know, for 32-bit systems we have 4 bytes of storage. Okay, so say 2, 3, 4, 5, 6, 7. So this is 1 byte and continuing. So we have, this is total of 1 byte. We have 8 bits here, and then it continues like this. It continues. Okay, so the correct answer here is that the leftmost bit is reserved for the sign. So this particular bit is what will store the sign. So it will be in binary, but it will store the sign, and the rest 31 bits that will be left will store the binary equivalent of the integer value. I hope that's clear. Okay, then let's move to the next question. So yeah, so in this question, what will be the output of the program? So it's basically we are including this. So this include, what exactly does it do? This is some kind of this is a preprocessor. This is called a preprocessor directive. So it tells the preprocessor that this stdio.h is a header file, and what we need to do is we need to include this header file in the code such that we are able to access the predefined functions that are available within this header file. Okay. Now this stdio.h has all the printing functions. So printing and scan, the printf, scanf, print err, all of this come under the stdio.h, the standard input output package. So this is the standard input output package. Okay. Now, okay, so next we have a main function where we are writing a is equal to 9, then you are printing a and it returning 0. So the output of this program, if I have to see it objectively, I would say the output would be in error. Why? Why? Because we have not really defined the data type of variable a. Is missing. Okay, so the data type of variable a is missing. Ideally, we should have defined it as int a is equal to 9. Only then it would have been the correct way to represent this. Okay, this was the correct way. This is the correct way of representation. Okay, so it will throw an error here. So the next question is find the value of x in this C code. So we have this function which is we are defining this intx properly this time, and we are initializing it with some expression. So what will be the value here? So what is the value of x in this particular C code? So we have specified int x. So x is a integer variable, and we are storing this particular value, whatever will be evaluated from this expression. So what exactly will happen here? What will be the answer here? So if we follow BODMAS rule, then yeah, there can be some answer, definitely, different answer. The answer here will be 19. Let me tell you why. So we have something called operator precedence and operator associativity. Okay, so these are two terms that we have, operator precedence and operator associativity. What does precedence basically mean? So we have operations such as okay, let's percentage, and we have plus, minus, and so on, right? So we have division, multiplication, and remainder operations, and we have addition and subtraction operations. So this is the order of precedence. Okay, so this is the order of precedence. That means that whenever in an expression a division, multiplication, or remainder function, remainder operator will occur, and alongside a addition or subtraction operator, first the division, multiplication, and remainder operation will take place. Only then after all such operations are over, only then the addition and subtraction operations will take place. Now in this case, that means this multiplication and division operation will occur first, and only then the addition operation will occur. Now what is operator associativity? So when we have multiple of the operators of the same precedence, so here we have the multiplication as well as the division operation. In such a case, we use operator associativity. So for this particular set of operators, we have associativity from left to right. So what does that mean? So this is for this particular category of operators. So from left to right means when we have operators of the same precedence in an expression, we will always evaluate from the left to the right. So because the multiplication and division operators are of the same precedence, the operator associativity tells us that we will evaluate from the left to the right. So we'll start from the left, we'll evaluate 4 into 5 first, so that gives us 20, then we'll divide by 2, that gives us 10, then finally the operators of the higher precedence are over, then we'll go for the addition, which is the lower precedence operator, we'll add, and finally we'll get 19. So I hope that is clear. So first the multiplication operation will take place because we are evaluating from the left to the right, so this is 20, then the division operation which occurs to the right of it, so divide by 2, 20 by 2 is 10, then finally higher precedence operators are over, so we are going for addition operation which is lower precedence, so plus 9 which is 90. Okay, Okay, so let's see the next question. So we have, what is the output of the following snippet? So we have in this, so we have defined, we have included stdio.h, we have defined the main function, and we are just defining a variable b, which is 57, and we are just printing the value using this percentage f. What is this percentage f? So it is a control character. Now this control character, while printing, it helps what exactly you want to print. Depending on that, you will use the control character. It is basically a placeholder for the value. Okay. Now there are different kinds of control characters. So percentage d is used for integers, percentage f is used for floating points, and percentage c is used for characters. I'll tell you more about this percentage 2.3f later on. And then we have the escape sequences, which is basically to format the output, okay, to make it more neat, or to have a better representation, better printing, to beautify it, basically. Okay. So this percentage f is used because it's a floating point variable, and we need to print the floating point variable in order to have the part of after the decimal to print it. You need to use percentage f. So the output here will be 57.0000000. So you will have 6 zeros here as the output, 57.00000. Okay, so this exactly will be the output here. Why? Because we are just specifying that we are printing it as a floating point, and a floating point, um, through the printing statement, the floating point will have a accuracy, that the float will have an accuracy of till 6 digits. Okay, so we'll have 6 zeros here. What if I don't really want this part after the decimal to be printed? What do I do in that case? So in that case, I'll use this kind of a thing, that is percentage 2.3f. So let's see what exactly it is. So what is this first part? This first part is the minimum number of characters to be printed. Okay. So when I say character, think of it, say here we have 6 plus 2 8 plus 1 9. So total of 9 characters to be printed. So here we have total of 9 characters to be printed. So this first part tells us the minimum number of characters to be printed. So there should be at least 2 characters which are getting printed. The second part tells us the number of digits after decimal, after decimal point. Okay. So up till 3 digits after the decimal point is what we want to be printed. So this is what it exactly means. Let's visit this example and see how it works. So you have a float variable which is a, which is the value is initialized to 4512.6526, and you print a percentage 0.3f. So in that case, what exactly will be printed? So the first part is not mentioned, so there is no minimum number of characters criteria here. The second part is 3, so up till 3 digits after the decimal, so somewhere around here it should stop. So what is the possible answers are C and D, right? Right. So here what exactly will be the answer? So the answer here will be D. So it will round up this because you have a 6 here. So when you ask it to have only 3 digits after the decimal point, it will round up this to 0.653, because it is higher than 5, it is greater than 5, so it will round it up to 0.653. Now say you had, instead of this, you had 4512.6523, and you wanted to see percentage 0.3f. So what would be the answer here? It would be 4512.652. Okay. Similarly, say I have how many digits here? 8 plus 8, we have, sorry, we have 4 plus 4, 8 plus 1, 9 digits here, right? So 9 characters basically. So what if I wanted percentage, say 10.4f. Okay, so we have 9 characters total, but we are saying that we need 10 characters at least. So what will be printed? So we'll have 4512.6526, and we'll have one space before it that will be printed. So it is basically a space. It's an empty space here. Okay, so this is what will be printed if you want 10 characters minimum to be printed. Okay, so hopefully I have been clear in explaining what was required. I have been clear in explaining how this you can control the number of digits while printing floating points and so on. Okay, so let's move on to the next question. So the next question that we have is okay, so we have a variable. This is 0 1. We are setting it to 0 1 1 0, and we are adding it with 7 and printing it because it's an integer variable. So we are using percentage %d here, and we are printing it. So what will be the output here? So this is a quite interesting kind of question. It's a kind of a different question than the ones we have encountered thus far. So the answer here will be 79. I'll tell you why. So if you see it just like this, it should be, which is 110. Deciding up with 7, answer should be 117. But why has it been written in this manner? Why is it starting with a 0? Why is this 0 present here? You could directly write 110, right? Why have we written 0100? Because that is how we represent an octal. So this entire thing, basically, because it is starting with a 0, it is an octal. So in octal, what will be the value? 8 to the power 0, 8 to the power 1, 8 to the power 2, and 8 to the power 3. Multiply this, add it up, so you'll have 8 plus 64 is 72, right? And then we add it up with 7, so final answer is 79. So if we want to define a variable, say I want to define 123, so this is a decimal. Okay, now if I want to say I have defined 0100 starting with 0, then it's a octal. Now if I want to have say 0b, some binary representations, so this, it starts with 0b, so it's a binary. And if it say starts with 0x, 5f, 8, 6e, something this manner, so it's a hexadecimal. Okay, so these are the different ways numbers can be represented or initialized to a certain variable. So if it starts with a 0, it is an octal. If it starts with 0b, it's a binary. If it starts with 0x, it's a hexadecimal. And if it starts normally without any zeros or any of this, it's a decimal. So these are the different ways in which you can represent or initialize a number. So here it's an octal, and we change it to decimal. So this is of base 10. So basically I'm saying that octal is basically equal to 72 of base 10, which is the decimal, and decimal we add it up with 7, so it is final answer is 79. Okay, so let's look at the next question. So the next question says that a is equal to 7 and b is equal to 10. These are two integer variables that have been defined properly. Then we are saying a is equal to b. So what happens? So we have, say, this space is a, this space is b. Initially we had 7 and we had 10. Now what a is equal to b says is that the value of b is copied into a. So now the value of a would be 10, right? And value of b remains unchanged at 10. Next what we say is b is equal to a. So what this says is the value of a gets copied to b. Now value of a is 10 already, and it just replaces this 10 here, and it still stays 10. value of a still stays 10, and finally what is this value? B is equal to 10. So here, after the execution of this code, the value of B will be 10. That is clear. So when we are doing this assignment operation, we are basically saying that A will take the value of B. In this operation, we are saying that B will take the value of A. So finally, the value of B will be 10. Okay. So let's move to the next question. So here we are basically trying to identify which is a invalid identifier. When I say identifier, it basically means a variable name. Okay. So let's visit the first option. We have extern AD. So extern is a keyword. Okay, extern is a keyword, but because we have, it's not just extern that we have written extern underscore AD. So it's a new variable name. So this is valid. It's a new variable name altogether. So this is valid. Then we have else. So in the next lectures, we'll see that if else are certain conditional statements. Okay, so both of these are keywords that we can't use. So else is the invalid identifier. What about the next one? We have some ACD underscore 1 to 3. It's alphanumeric. It's not starting with a number. So it's a fine. This is valid. Okay. And the final one is underscore 1 to 3 AC. So it starts with an underscore. So it's not recommended, right, to start with an underscore. But if you think about it, it's still valid because there is no library name in this name. So it's not, although it's not recommended, it's also not invalid. So here the invalid one is else. Okay, so these are the last two questions I have for you today. So it's related to the variable addresses. So we learned that every variable, when you write int a is equal to 9, so some space in the RAM, we have, this is the RAM, and some space in the RAM get allotted with this variable, which is, say, this 4 bytes of space will be allocated in the RAM, and it will store the value of 9. Okay, it will store the value of 9. Okay, now keeping that in mind, let us solve the first question. So we are inputting to, we are declaring to, so this is the basically declaring two integers. Okay, and we are taking the value from the user using the scanf statement, which is basically uh, uh, defined in the stdio.h, and say we are inputting 5 and 6 as the input. Okay, I have inputted 5 and 6 as the input, and then we are defining another variable called sum, and we are saying sum is equal to a plus b, which is basically 5 plus 6, so sum will be 11. Okay, now I am printing sum is equal to percentage %t, and I am printing something, right? So what will be the answer? What will be the output here of this entire code? So in all probability, the output here will be an error. Why? Because you see in the AND statement, I have used this ampersand symbol. Okay. So this ampersand symbol basically say what is sum? Sum is a variable, right? Now, if I want to uh, get the value of sum, so I would write printf sum is equal to percentage %t sum, and that would give me the output that sum is equal to 11. Okay, this would be the output. Now what I have done is I have used ampersand sum. So ampersand sum is basically, it is referring to the address of the variable. Okay, whenever we use ampersand, it is called a dereferencing operator. So it okay, might be often a referencing operator. So basically, for a variable, for any variable, if you use ampersand sum, ampersand preceding the variable name, it basically changes it to the address of the variable. So here we are trying to print the address of the variable using an integer. So address of the variable is not an integer. Okay, so that is why it will give an error. So if we wanted to print like the address of the variable properly, what would we have to do? So we would write sum is equal to percentage %p, which basically stands for a pointer variable, which we will learn in much later weeks. So if you want to print the address, print percentage %p. So in that case, you will have sum is equal to sum 0x5fa6, something in hexadecimal. We will get a long value in some hexadecimal. So this will be some hexadecimal value that you will be getting. So this is basically the address of the variable sum. Okay, so that is how you will get. You need to use percentage %p if you want to print the address. Okay. Instead of percentage %d, you use percentage %p. Only then you will get this, or you don't use ampersand, you will get the value of this variable sum. Okay, so I hope that's clear. So this is the final question for today. So what will be the output of this following C code? So you have included stdio.h, you have this main function, you have defined the floating point value a is equal to 7.0, and you are printing out percentage %12, so 2 digits after the decimal. Okay, so all the answers should be up to 2 digits after the decimal, right? Okay, so sorry for the mistake. And then finally we are printing some kind of expression here. Okay, so when I talked about the precedence earlier, anything that is in parenthesis will have a higher precedence than all of this. So this is the order of precedence. Okay. So parentheses have a higher precedence than all of these operators. So 13 by 5 will be evaluated first. So when you evaluate 13 by 5, the answer is 2.6, right? So what will happen here? So because we are writing that it's 13 by 5, so basically we are dividing an integer with an integer. So the answer automatically is brought down to an integer. So what happens? Only the 2 part is taken here, not the 0.6 part. So here it will write 13 by 5 as 2, not as 2.6. This will not be written. This will be written. So when you do that, it will be 2 into 7.0. This will come to 14.0, and then it will add 10, and it will become 24.0. So the answer here will be 24.00. This will be your answer. But what happened here? So we were defined and we divided int with int. So the answer is also an int. That's what the C compiler understands. Now, how would you debug this? So if you had written 13.0 by 5 or 13 by 5.0, in this case, the answer would have been 2.6. Why? Because you would have been dividing a int by a float, and that gives us a float. Why? This is something called implicit typecasting. Okay, let me just write it here. So I divide a int by float or a float by int. That gives me a float. So this is something which is called implicit typecasting. So we'll look at this in the next lectures. It is also called type conversion. Okay. So we'll look at this. There can be explicit as well as implicit typecasting. So float is basically, here you can remember it like float is a higher category of data type than int. So anything when you divide or operate, like you add a float with a float or any kind of operation between an int and a float will result in a float. Okay. So that is what you can remember. So here, because we are operating between two ints, the value was also an int, which is 2. This part of the decimal was ignored completely. and then it multiplied with the a. A is 7.0, so it multiplied int with a float, so that resulted in a float. Now it again added up with the int, so the answer was still a float because float is a higher data type, like I said. So any operation between int and float will result in a float. That is what you can see from here. So the answer here will be 24.00. Okay, fine. So those were all the questions, sample questions that I had for you for this particular tutorial session. So we'll see you in the next class. So next Tuesday, 6 to 7 p.m. We shall have our next tutorial session. If you have any doubts regarding this lecture or this particular session, or in say in any of the previous weeks, so you can directly ask me questions in the next session, or you can post your questions in the forum. I'll answer them there. Okay, so thank you for attending.